Welcome to the Deep Dive. I'm thrilled you're joining us today. If you're tuning in, you've probably been swamped by headlines about new AI models or, generative video breakthroughs
Right.
and all that software that promises to practically do your job for you.
Yeah, it's everywhere.
It really is. So today we're taking a major step back from all that software hype to look at the physical reality of how this all actually functions. Our mission for this deep dive is to shortcut your way to being intimately familiar with the literal physical infrastructure powering the global AI boom.
And it's a completely different world under the hood.
Totally. And to do that, we are pulling our insights directly from a stellar primary source. We're looking at Broadcom's Q1 2026 earnings report and the accompanying live conference call transcript, which just dropped on March 4th, 2026.
It is wonderful to be here. When we discuss artificial intelligence, it is remarkably easy to get lost in the perceived magic of the algorithm.
Oh, for sure.
We tend to think of the cloud as this invisible, ethereal entity. But in reality, the cloud is just a colossal network of someone else's computers. Right now, the largest tech companies on the planet are locked in an arms race.
A massive arms race.
Exactly. An arms race to build the most powerful computing systems in human history. And Broadcom is the company standing right at the center of that battlefield, quietly supplying the essential architecture.
Okay, let's unpack this because the sheer scale of the numbers we are looking at from this report is almost hard to comprehend.
It really is staggering.
Broadcom isn't just casually riding the current AI wave. They are fundamentally the ones building the pipes and the engines that make it possible. On this call, they predicted a clear line of sight to an astonishing $100 billion in AI revenue in the year 2027 alone. 100 billion.
What's fascinating here is the stark contrast between the public perception of the AI industry and the ground-level hardware reality. The broader public is fixated on consumer-facing software applications. But this deep dive is entirely about the behind-the-scenes engineering. Broadcom might not be a household name in the way a consumer app is, but they serve as the indispensable architect for the world's biggest tech titans.
Indispensable is the word.
Truly. Without their specialized custom silicon and networking hardware, the platforms you and I use every day simply could not function at scale.
Let's get into the staggering financial reality of this Q1 bombshell because the numbers are wild. For the first quarter of fiscal 2026, Broadcom reported $19.31 billion in total revenue.
Which is huge.
Yeah, that represents a 29% jump year over year. But looking past the top line, the profitability metric is what really stands out. They generated $13.1 billion in adjusted EBITDA.
Wow.
Right? That means 68% of their revenue is converting into profit before interest, taxes, depreciation, and amortization.
A 68% margin for a business heavily involved in physical manufacturing and hardware is practically unheard of.
Usually hardware is a low-margin game.
Exactly. It demonstrates the immense operating leverage that comes with their dominant market position. When you operate at this level of scale and efficiency, every additional dollar of revenue flows beautifully down to the bottom line.
And the drivers beneath that total revenue number are even more revealing. In Q1 alone, their AI-specific chip revenue hit $8.4 billion. That is up 106% compared to the previous year.
Crushing expectations.
Completely shattered them. Then, looking at their guidance for the next quarter, Q2, the acceleration steepens. They are projecting $10.7 billion in AI revenue. That marks a 140% year-over-year acceleration.
This brings us back to that monumental revelation from CEO Hock Tan during the analyst Q&A. It is remarkably rare for a chief executive to offer specific revenue visibility that far into the future.
Let alone to the tune of $100 billion.
Right. But he explicitly outlined that $100 billion AI revenue target for 2027. And he was highly intentional in clarifying to the analyst that this figure is derived entirely from chips.
Just chips.
Just chips. Specifically, custom accelerators, switch chips, and digital signal processors.
And they are certainly not hoarding all that cash. They're aggressively rewarding shareholders. In Q1, Broadcom returned $10.9 billion to investors.
That's a massive return.
It breaks down into $3.1 billion in dividends and a staggering $7.8 billion in stock repurchases. Plus, they just authorized a brand new $10 billion share repurchase program running through the end of 2026.
So they are incredibly confident.
Exactly. For you listening today, if you have been reading financial news and wondering whether the so-called AI bubble is pausing or running out of steam, Broadcom's massive forward guidance suggests the exact opposite. The heavy infrastructure spending is actively accelerating.
The capital expenditure from the major cloud providers is no longer a theoretical projection. It is materializing as locked-in multi-year revenue on Broadcom's balance sheet today.
But those billions of dollars have to be coming from somewhere. Which brings us to a highly intriguing part of this earnings call, the reveal of Broadcom's extremely exclusive client list.
Yes, the Secret Six.
Right. They do not sell these custom AI XPUs, which are highly specialized AI accelerators, to just anyone on the open market. They only build them for 6 specific customers in the entire world.
It is a brilliant, highly concentrated business model. Instead of designing a general-purpose chip and attempting to market it to thousands of different companies, they partner deeply with the absolute titans of the tech industry to engineer bespoke silicon.
Bespoke silicon, I love that phrase.
During this call, we received an unprecedented look at who those customers are and the metrics they use to measure their deployments. And interestingly, they aren't just counting individual chips. They're measuring deployment footprints in terms of gigawatts of power.
Wait, measuring computing power in gigawatts?
Yes.
That is typically how we talk about the output of a nuclear power plant, not server racks.
I know.
Break down what that actually looks like for these specific customers based on what Hock Tan revealed.
It highlights the extreme power density of these data centers. A gigawatt of power consumption requires dedicated substations and localized grid planning. According to the call, Google is showing robust demand for their 7th-generation Ironwood TPU.
Okay, so that's Google.
Then you have Anthropic, deploying 1 gigawatt of compute in 2026 with expectations to surge over 3 gigawatts in 2027.
Wow. He also directly addressed Meta, right?
Yes.
Because there had been rumors circulating that Meta might be pulling back on their custom silicon efforts. But Hock Tan flatly denied that. He said Meta's MTIA custom accelerator roadmap is alive and well and will scale to multiple gigawatts in 2027.
We also got confirmation of a major new addition to the Secret Six list, OpenAI.
Ah, OpenAI.
Broadcom confirmed OpenAI is their newest customer, preparing to deploy their first-generation custom XPU in volume by 2027, also at over 1 gigawatt of compute capacity.
Adding all of this up paints an astonishing picture. Analyst Stacy Razgon actually did the math live on the call.
That was a great moment.
Just picture an analyst furiously punching calculator buttons on a corporate finance call to do electrical engineering math. He added up the gigawatts, and Hock Tan confirmed the calculation. Broadcom is looking at close to 10 gigawatts of compute deployed across these customers in 2027 alone.
It is a staggering physical footprint, 10 gigawatts.
But it begs a really obvious question from a business perspective. These hyperscalers, Google, Meta, OpenAI, they have practically infinite capital resources.
Right.
Why can't they just design and manufacture their own chips entirely in-house? What prevents them from cutting Broadcom out of the equation?
That is the multi-billion-dollar question, and it comes down to a concept known in the semiconductor industry as COT, or customer-owned tooling.
Customer-owned tooling?
Yes. In theory, a company could try to become entirely self-sufficient. They could bring their own blueprints to a fabrication plant. But an AI platform simply cannot afford a chip that is merely functional. To compete against other models and to compete against NVIDIA's relentless performance upgrades, these companies require the absolute peak of silicon design.
Right. It can't just be good enough.
Exactly. They need the most advanced packaging and world-class Certus technology, which handles the high-speed data transfer between the chips.
So it is not just about drawing a clever architecture on a whiteboard.
Precisely. Designing a chip in a simulation is one thing. But Broadcom provides the high-yield manufacturing at scale.
Yeah.
Can you produce hundreds of thousands of these microscopic, incredibly complex structures quickly without half of them failing and bankrupting your project?
Right. The yield is everything.
Broadcom has spent over 2 decades perfecting this. They provide the necessary time-to-market advantage.
Here's where it gets really interesting because the types of workloads these chips are handling are fundamentally evolving. We frequently hear about general-purpose GPUs, which are incredibly powerful.
Right.
But as AI models become more specialized, utilizing architectures like mixture of experts, customers require custom XPUs that are hard-coded for very specific tasks.
To clarify for our listeners, think of a general-purpose GPU as a massive, highly capable supercenter. It can do a little bit of everything well, but a mixture of experts model operates more like a committee of highly specialized consultants.
I like that analogy.
If you can hard code a custom XPU to execute only the specific mathematical functions that one expert needs, It becomes drastically faster, cheaper to operate, and consumes far less electricity.
And this becomes especially critical when separating the two main phases of artificial intelligence,
Right.
training the model and inference. Inference being the phase where you and I actually interact with the model to generate a response.
Right.
Hock Tan made a brilliant strategic point about this on the call. He described a necessary leap of faith these companies must take.
The timing is brutal. Training a massive frontier model takes months, sometimes stretching over a year. Hocktam pointed out that if you wait until your model is perfectly trained to start designing the specific inference chip that will run it efficiently, you will find yourself a full year behind your competitors in actually monetizing your product.
That's a huge delay. So if you're the CEO of a hyperscaler, you literally have to be designing your custom inference chips simultaneously while the model is still learning.
That required leap of faith explains why the relationships between Broadcom and these 6 customers are so deeply entrenched. This is not a transactional vendor relationship where a company orders hardware out of a catalog.
They aren't just buying off the shelf?
Not at all. They are sitting in the same room co-architecting multi-generational roadmaps together.
But having the most perfectly designed, custom-built XPU in the world doesn't actually solve the problem of running a data center if they can't talk to each other.
Exactly.
Which brings us to the unsung hero of the AI boom, networking and copper. When we visualize AI hardware, we always picture the processing chips. We rarely think about the cables and switches connecting them.
It's the invisible glue.
Yet according to this report, AI networking made up a full 1/3 of Broadcom's total AI revenue in Q1 and is accelerating to 40% in Q2.
A single AI chip, regardless of its processing power, is practically useless in isolation. You have to network tens of thousands of them together to train these models. Shuttling petabytes of data between those chips without creating a traffic jam is a phenomenally complex engineering challenge.
And Broadcom detailed their dominance in this space with some serious technical specifications. Their Tomahawk 6 switch is currently the only one on the market hitting 100 terabits per second paired with their 200G SerDes technology. And next year, they're slated to release Tomahawk 7, which will double that performance entirely.
If we connect this to the bigger picture, it helps to understand how these massive data centers are physically laid out. The industry uses 2 main concepts, scale out and scale up.
Okay, let's break those down.
Scale out refers to connecting entirely different massive clusters of computers together across the expanse of a data center. For scale out, Ethernet is the undisputed standard, and Broadcom leads with 1.6 terabit optical transceivers.
Optical meaning lasers, right?
Yes. Optical means they are utilizing lasers to send data over longer distances via fiber optic cables.
But the scale-up side is where we get a major surprise. Scale-up refers to connecting chips directly to each other within the exact same server rack. And for this, Broadcom is aggressively pushing their customers to stick with direct-attached copper or DAC for as long as possible, rather than transitioning those short connections to optics.
It is a masterful strategic play based purely on physics.
Really? How so?
Well, the tech industry has a well-known affinity for bright, shiny objects, and replacing all wiring with lasers sounds highly futuristic. However, optical connections require converting electrical signals to light and back again. That process generates significant heat and consumes precious electricity.
And those are 2 things data center operators are desperately trying to conserve to lower their air conditioning and power costs.
Exactly. Broadcom's proprietary technology allows traditional, inexpensive copper wiring to stretch to 200G and soon 400G speeds. This maintains lower latency and drastically reduces power consumption.
This networking discussion actually led to arguably the most entertaining moment on the entire earnings call.
Oh, the analyst question.
Yes, an analyst from UBS, Timothy Arcuri, asked a question regarding gross margins. He expressed concern that selling these heavy, full networking racks of copper and switches would drag down Broadcom's overall blended gross margins. Hock Tan flat out told the analyst he must be hallucinating.
Hallucinating. It was an unusually candid moment for a finance call.
It really was. He made it crystal clear that Broadcom's margins are rock solid at 77%. He emphasized that they have refined their manufacturing yields so perfectly that selling more physical AI hardware does not dilute their profitability in the slightest.
That underscores management's absolute confidence in their operational efficiency. They are not attempting to buy market share by selling low-margin hardware. They command a premium because their technological integration is unmatched and their manufacturing processes are ruthlessly optimized.
Now, building those physical racks of copper and silicon requires an immense amount of raw material. This brings up a critical competitive moat that Broadcom revealed, their bulletproof supply chain.
In the current semiconductor landscape, raw materials are severe bottlenecks. We're talking about highly specialized components. On this call, Broadcom announced they have fully secured their capacity for T-glass, substrates, high-bandwidth memory, and leading-edge semiconductor wafers entirely through the year 2028.
Can you clarify some of those terms for us? What exactly is a substrate or T-glass, and why is it such a bottleneck?
Sure. Think of the substrate as the actual physical foundation, the highly engineered base layer that the microscopic chip sits upon. T-glass refers to advanced glass substrates that offer superior thermal and electrical properties compared to traditional organic materials.
So if you don't have that base layer,
If you lack that base layer, it doesn't matter how brilliant your architectural design is, you physically cannot construct a chip. And high bandwidth memory, or HBM, is akin to giving a processor a massive, ultra-fast filing cabinet right next to its desk, rather than forcing it to walk down the hall to retrieve data.
got it. So by locking up the supply chain for these foundational elements through 2028, Broadcom is giving their Secret Six customers the certainty required to make multi-billion-dollar strategic bets.
And conversely, it creates a near insurmountable barrier to entry for potential competitors. Even if a rival company miraculously designs a superior chip tomorrow, if they have not already secured the T-glass, the substrates, and the HBM capacity for the next 3 years, they are entirely locked out of manufacturing at the scale these hyperscalers demand. Foresight in supply chain management is proving to be just as critical as the silicon design itself.
Before we synthesize all of this, we should briefly touch on the other half of Broadcom's business that provides a massive financial anchor: the infrastructure software segment. It remains steady and highly reliable. Q1 revenue for software was $6.8 billion, and VMware's annual recurring revenue is growing at a healthy 19%.
Some analysts have historically questioned why a hardware giant would acquire software companies like VMware, or whether the rise of AI would disrupt traditional virtualization software. Hock Tan addressed this directly, explaining that AI is not disrupting VMware. It is actively enhancing its value proposition.
How does that integration work in practice, on the ground?
VMware Cloud Foundation, or VCF, serves as the essential software layer in the data center. It seamlessly integrates the CPUs, the GPUs, the storage, and the networking into one common high-performance environment. As generative AI workloads become increasingly complex, it generates more demand for this foundational infrastructure software.
Oh, I see.
VCF acts as the permanent abstraction layer between the complex AI applications and the physical chips we have been discussing.
So what does this all mean? When you look at the custom hardware dominance, the multi-year supply chain lockup, and the software integration all operating in tandem,
It means Broadcom is not treating the artificial intelligence boom as a short-term transactional hardware cycle. They have positioned themselves as the structural bedrock of the industry. They are deeply embedded in the strategic, decade-long roadmaps of the world's most powerful developers. Their visibility into future revenue is so clear, specifically because their customers are inviting them into the planning room to co-architect the future of computing.
we have covered some seismic ground today. We are looking at a company guiding for 47% total revenue growth next quarter. We see an incredibly secure, bulletproof supply chain locked in through 2028, and we have a clear $100 billion path paved by custom silicon for tech giants like OpenAI, Google, Anthropic, and Meta.
All unified by dominant networking technology.
Yes, technology that keeps the data flowing efficiently over copper and glass. Here is your big takeaway to keep in mind. The next time you sit at your desk and use a generative AI assistant or an AI-powered search engine or a complex enterprise tool, there is a remarkably high probability that your prompt and the data generating your answer is flowing directly through a custom Broadcom XPU connected by a Broadcom Tomahawk switch. They are the unseen physical infrastructure of the AI age.
This raises an important question for all of us to ponder as we look toward the future. We've heard today how brilliantly Broadcom has secured the silicon, the copper, the advanced substrates, and the manufacturing through 2028 to support 10-plus gigawatts of AI compute from just 6 companies.
Yeah.
But look at the broader world outside the data center walls. How will our physical real-world power grids and local energy infrastructure handle a single technological sector deploying tens of gigawatts of newly concentrated energy demand in just the next few years? The chips are clearly ready, but is the grid?
That is a phenomenal question and definitely something we will all be watching closely as this physical infrastructure continues to scale. Thank you so much for joining us for this deep dive into the literal nuts and bolts of the AI revolution. Stay curious, keep learning, and we will catch you next time.